Hey guys, in this video we're going to be learning how to graph linear functions. So linear is when you have a graph and the function is just a straight line. So in this direction, it could be in this direction, up here, or, kind of just a straight line. Those are linear functions. So when we're graphing linear functions, we have to know about something called slope form. So slope form. So we write our equation in slope form, and this means y equals mx plus b. So in this case, the y is the y value. The m is the slope. The m is the slope. X is the x value. Let's use a different color. So the x is the x value. And finally, the b value is the y-intercept. So y-intercept, yeah. So let's look at an example. So we have the expression. So y equals 1 over 3 x plus 2. So when we have our expression like this, it's important to identify what is your slope, y-intercept, x value, y value, to make sure you're getting the right answer. So what is our slope? Our slope is rise over run. So how many times you go up over how many times you go, you run left and right. So rise can be up or down, run can be left or right. So for this example right here, we can see that 1 over 3 is the slope because it's being multiplied by x. Whatever number is multiplied by x is the slope. So this is the slope. The number 2 over here, that is our y-intercept. So y-intercept. The y-intercept is the value that you get when you plug in 0 for x. When x equals 0. So we're looking at the y value when x is 0. So we can make a table. We're going to start off by making a table. So an x and y table. And we're going to plug in a few points. So let's start with 0 and get our y-intercept. So 0 over here, so 0 times 1 over 3 gives us 0, right? So this whole thing over here equals 0 plus 2 equals 2. And that is our y value. So we have 2 here. So our first point is going to be 0, 2. Our next point is going to be, and you can pick any number, but I'm going to pick 3 because that's going to cancel out the 3 on the bottom over here. So 3 over 1. So when you have 3 over 1, 3's cancel out, 1's cancel out, and you're left with 1 plus 2. So remember, this equals 1, not 0. So 1 plus 2 equals 3. So at point 3, when x is 3, y is 3. So we can plot that. So 1, 2, 3. 1, 2, 3. So let's pick a negative value. So let's say we have negative 3. So again, that 3 cancels out. So negative 3 and 3, we don't cancel out the negative. That stays. So 1 cancels out. So this whole thing becomes negative 1 now. So when you multiply 1 over 3 times negative 3 over 1, so 1 times negative 3, that's negative 3. And then 3 times 1 is 3, and this just equals negative 1. Just for clarification, so negative 1 plus 2, that gives us 1. So we're going to go to point negative 3 on the x side, and we get 1 for that. So 1 to negative 3, and then 1 over here. Once you've got about 3 points, you can now draw your line. So something like this, just going forever. So let's examine the slope right now. So we said that our slope was 1 over 3. So 1 over 3. So in this case, are we rising by 1? So rise by rise over run, right? So rise over run. So we're rising up 1. If it's positive, so up is positive, and then this side, right, is positive as well. So 1 is positive, so we're going up 1, and then we're going to go 1, 2, 3. So we know that we did this right. So again, up 1, 1, 2, 3 to the right. So that's how the slope works. Let's try a different example. So let's say we had 2x plus 4y equals 12. So first of all, we need to make sure that our equation is in slope-intercept form or slope form. So that is y equals mx plus b. So we're going to go down here and say y equals mx plus b. So we need to get the y value isolated. We can start that by subtracting 2x on both sides, so minus 2x. We're going to get, so we're going to get 4y. Let's use a different color. So 4y equals 12 minus 2x. Next, we can divide the 4. So divided by 4, divide this by 4, and this by 4. So now we're going to get y. So y equals 12 divided by 4 is 3 minus 1 over 2x. So this is really in slope-intercept form. So this is this, but if you want to make sure that the m and x are on this side, we can do that as well. So we can rewrite this as y. Let's write this here. Y equals negative 1 over 2x plus 3. These are the same. So same, but if you wanted in slope-intercept format, so this one right over here, you can just bring this negative 1 over 2x in the front and then move the 3 to the back. Okay, so now that we have that, we can now make our x and y table. So we're going to start off by finding the y-intercept. So remember, when we were talking about the slope-intercept form, we said the b value was always the y-intercept. So our b value here is 3. So this is our y-intercept. Y-intercept. And at y-intercept, our x value is 0. So 0, 3. Next, let's choose the point 2 so that the 2 on the bottom here cancels out. So when we have that, it would be y equals negative 1 over 2 times 2 over 1 plus 3. 2's cancel out, negative 1 and 1. The negative remains, so this part equals negative 1 plus, bring the plus 3 down. So negative 1 plus 3 is 2. So at the x value of 2, we have a y value of 2. Let's do one more point. Let's do -2 this time. So let's say we had y equals -1/2 times 2 over 1 plus 3. This goes -2. So here we have the 2 cancels out, 1 cancels out, and here we have -1. So negative times negative, so negative here, so that would be, so negative times negative, that gives us positive. So we just have +1. 3 comes down, so +3, and that gives us 4 for the y value. So 4, and this is when the x value is 2, -2. So now you can draw your graph. So I'm going to draw it right over here. So we have 0, so 0.03, 2, 3, so right about here. And then 2, 2, so 1, 2, 1, 2. And then we have the point -2, 4. So 1, 2, 3, 4. So let me just move this a little this way. Okay. So now we connect the dots. Okay. Oops. So now we would have a negative slope. So when you have a negative here, this would be a negative slope. When it's pointing this way, it's negative slope. So negative slope. But if it was pointing this way, then you have a positive slope. So this is a negative slope over here. And then we can check that out. So we're slope is equal to rise over run. So our rise is negative. Remember, we can never have a negative in the denominator. The negative just moves up to the numerator. So we're going to rise -1. So that means we're going to go down -1 in this case. So down 1, and then we're running to the right 2. So 1, 2, and that works. Let's do it again. So 1 down, 1 to the left, 2 to the left. So this works out. So finally, let's do one more example. So let's say we have something like this, y equals 5. So you're probably saying, well, there's no x value and there's no b value, so how would I solve this? Well, it's kind of intuitive. So let's say we have these points here, and let's say this was 1, 2, 3, 4, 5. Okay, so let's do this here. Okay, so y is equal to 5. So 1, 2, 3, 4, 5. So this was 5. And we're saying that y is always 5. So y equals 5. So regardless of the x value, your y value is always going to be 5, no matter where it is. Over here, over here, over here, over here, here, everywhere. So all you're just going to do is draw a line going this way. So y is always 5. But if it was this way, so if we had x equals 5, then it's kind of different, but very similar. So this would be 1, 2, 3, 4, 5. So this would be 5. So regardless of the y values, regardless of these values, x is always going to be 5. So it's going to go this way. So x is kind of vertical, y is horizontal. It's different. It's kind of like counterintuitive in this case with the horizontal and the vertical. Just think about it. Regardless of the x values over here, the y value stays constant. And over here, regardless of the y values, the x stays constant.